All right, hey guys, now we're looking at lesson number 2. So a rhombus has all the same properties as a parallelogram. And just to recap that means that opposite sides are congruent and parallel, opposite angles are congruent, and then consecutive angles are going to be supplementary. Your diagonals are also going to bisect each other. The one thing that makes a rhombus unique is that it has 4 congruent sides. So it's a parallelogram with all 4 sides that are equivalent. The first thing that we need to know about a rhombus is that our diagonals are perpendicular, meaning they intersect at a 90-degree angle. Now each diagonal also bisects the opposite angles and lastly, number 3, all 4 sides are congruent and opposite sides are parallel. So when we take a look at example 1, we want to use those properties of rhombi. We know that FK is 5 and that FG is 13. We want to find KJ. So we're looking for right here. And I know that these diagonals bisect each other, and I also know that they intersect at a 90-degree angle. So to find GK right here, I can use Pythagorean theorem. So I can say 13 squared minus 5 squared will equal GK squared. Well, 13 squared is 169 minus 5 squared, which is 25, and that gives us 144. When we take the square root of that, we get that GK is equal to 12, and because GK is 12, that means that KJ is also equal to 12. When we take a look at 1b, now they're telling us that the measure of angle JFK is equal to 6y plus 7, and that the measure of KFG is equal to 9y minus 5. So now we're going to use that third property where we know that diagonals bisect opposite angles. So angle GFK and angle KFJ are congruent. So I can take 6y plus 7 and set it equal to 9y minus 5, which tells us that 3y is equal to 12 and that y is equal to 4. Right, now looking at squares. Squares have 4 congruent sides and 4 right angles. So that's why squares are rectangles. Squares are also rhombuses, but not all rhombuses and rectangles are also squares, which takes us to this infographic right here. Squares are both a rectangle and a rhombus, but not every single rectangle is a square, and not every single rhombus is a square. We have some theorems for rhombi and for squares. 617 states that if the diagonals of a parallelogram are perpendicular, then it's a rhombus. So this is when we look at diagonals being perpendicular. Let me rewrite that, that's not cute. Diagonals are perpendicular. Now 618 states that if one diagonal of a parallelogram bisects a pair of opposite angles, so we're looking at a pair of opposite angles and they're bisected, then we know that it is a rhombus. Notice that both of those first two stated that we already knew it was a parallelogram. 619 states that if one pair of consecutive sides of a parallelogram are congruent, the parallelogram is a rhombus. Again, knowing it's already a parallelogram. And then lastly, if a quadrilateral is both a rectangle and a rhombus, then it is also a square. So we're going to take all of these now and start using those properties. So let's turn the page, and we want to make a proof. So we're going to go ahead and start and just set up our table with our statements and our reasons. Now they're telling us to write a paragraph proof. I'm going to go ahead and say no. We're going to do a 2-column proof. The first thing that we're given is that SQ is a perpendicular bisector of PR. So knowing that, I now know that PM and MR are congruent because it's a perpendicular bisector. And I also know that SMP is a right angle. And again, my reasons was because this was given. The second statement, because I've already taken care of that. And actually, I'm making a silly mistake because we cannot skip steps. Because it was a perpendicular bisector and based on my annotations, my second, I know that MPM is congruent to MR, and that is definition of bisector. And the third thing that I knew was that the measure of angle SMP was 90, because that's the definition of perpendicular. So now we're going to move on to our second statement that PR is a perpendicular bisector of SQ. And our reason for that was given. And now because of that statement that we were given, knowing that PR is a perpendicular bisector of SQ, I know that SM must be congruent to MQ because that's the definition of bisector. And then I know that the angle, so let's go ahead and mark that. I know that the angle SMR is equal to 90 degrees because that's the definition of perpendicular. You guys, I want to apologize if y'all can hear my dog in the background. She has the zoomies. The last thing that we're told is that the triangle RMS, so we're looking directly right here, RMS, is isosceles. Because that is isosceles, and we know that this is a right angle right here, SM and MR must be congruent to make that a 45, 45, 90 triangle. So we know that SM is congruent to MR because definition of right triangle. We're going to scroll down a little bit. And we want to prove that it's a square. Well, we've proven that it's a parallelogram already. We've proven that it is also a rhombus. Because it is a rhombus and a rectangle, we know that it is now a square. So let's take a look at number 3, using conditions of rhombi and squares. Number 3, quilting. Kathy is designing a quilt with blocks shown, like the one shown. For part A, if she marks the diagonals of each yellow piece and determines that each pair of those diagonals are perpendicular, can she conclude that that is a rhombus? And no, we cannot conclude that yet, because if we're looking at just the yellow pieces and we find that our diagonals are perpendicular to each other, that is not enough information to tell us that it is also opposite sides are congruent, all four sides. So no, we do not have enough information because we only know it's a excuse me, it's a parallelogram. Right. Then for part B, if all four measures of the green piece have the same measure, so same measure right here, all four sides, and the left sides have the same measure, can she conclude that that green piece is a square? And when we look at that, we can actually conclude that yes, that is a square, because we know, one, it is a quadrilateral, meaning the interior angle sum is 360. And so when we take 360 and divide it by 4, we get that 90 degrees is for each angle. So opposite sides are congruent, so it is a parallelogram. Excuse me, not opposite sides, opposite angles. Let me erase that real quick for you. Opposite angles are congruent, so it's a parallelogram. And because it's a parallelogram with 4 right angles, it is a rectangle. And because we know that consecutive sides have the same measure, that tells us it's a rhombus. So because it is a rectangle and a rhombus, it is a square. Sorry for taking you guys all the way down to the bottom. So now we want to take all of this and apply it to coordinate geometry. So we're given 4 points. We are given 5, 0, which is J. We're given K, which is 8, negative 11. Let me make sure I count it all the way. It's hard to see when they're so little. Right? And that's going to be K. We're given that L is negative 3, negative 14. So I'm going to have to go 1 off for L. And M is negative 6, negative 3. We want to determine whether that parallelogram is a rhombus, a rectangle, or a square. And then we want to list all that apply. So the first thing that we'll do is we can check diagonals. Because if the diagonals are congruent, we know that it is a rectangle. So I'm going to check the distance of MK and JL. When I look at MK and I look at the x coordinates, the distance between them on a number line is 14. And the distance between the y coordinates on the number line, again, is 14. Oh, excuse me, not 14. 8. So we get 196 plus 64. So we have the square root of 260. And now we need to check JL. So I look at the x-coordinates of JL, which are 5 and -3. Now those are 8 apart. And the y-coordinates of J and L are 0 and -14, so those are 14 apart. So we're still going to get 196 plus 64, which still gives us 260, or the square root of 260. Now because those diagonals are equivalent, now we know it's a rectangle. Now from there, we just want to see if it's actually a rhombus. Now we know those diagonals are congruent. Now let's see if they intersect at a 90-degree angle. So we want to find the slope of MK and the slope of LK. So when I look at MK, I'm going to actually just look at the points now since I haven't connected all of my dots. MK is -6, -3, and 8, -11. So y2 minus y1 becomes -3 minus a -11, or positive 11 actually, over -6 minus 8. So we get a positive 8 over a -14, which simplifies to -4 over 7. So now we need to find LK. Now for LK, when I look at y2 minus y1, I get -14 minus 0 over -3 minus 5, which gives us -14 over a -8, or a positive 7/4. Now because -4 over 7 and 7 over 4 are opposite reciprocals, meaning they have different signs and their fractions have flipped, those are perpendicular slopes. So now we know that it is also a rhombus. So because it is a rhombus and a rectangle, we know that yes, it is a square. So yes, it's a square because it is a rhombus and a rectangle. All right, you guys, there are 2 questions on the back or on the additional side of your notes. Now, the first thing that you're going to do, because those are going to be independent, is you always want to check first to see if your diagonals are congruent, just like we did right here. If you know that your diagonals are not congruent, it will not be a rectangle. So then you need to check to see if it's a rhombus by looking at the slopes of the diagonals to see if they are perpendicular. If the slopes are not perpendicular, it is not a rhombus. If something can be a rhombus but not a rectangle, and something can also be a rectangle but not a rhombus. If you've proven something like we did here, that it is a rectangle and a rhombus, please make sure that you list that it is a square. Because once something is a rhombus and a rectangle, by definition, it's also a square. Right, you guys, now that you have completed the lesson, your task for the remainder of class is to finish your homeworks for 6-4 and 6-5. With any remaining time in class, you guys can go ahead and work on those Imagine Math lessons. I miss you guys, and I will see you next Tuesday.